Welcome to Green Star 1. Your learning intention is to identify and explain how a 3D shape and its net connects. The success criteria is I can match complex nets to their 3D shapes using shape property language in my justification. Let's have a look at some of the terminology we'll be using during this video and keynote. Complex nets refers to more advanced nets of complex 3D solid shapes. Complex nets have numerous faces, edges, and vertices. Some other terminology we'll be using will be base, sides, and top. The base refers to the panel of the net that forms the bottom of the 3D solid shape. Sides refers to the panels of the net that forms the sides of the 3D solid shape. And top refers to the panel of the net that is the top of the 3D solid shape. We'll be looking at a range of different nets throughout this keynote and the video. But let's start with the cube first. To identify that the cube's net is indeed this T net here, we can use some skills to help us instead of just knowing. The first thing that we can look at is that this panel here is going to be our bottom panel. Therefore, it will be the bottom panel of the 3D solid shape, the cube. We can then look at the four panels around the bottom panel. As we know, when we fold them up, they'll become the side panels of the 3D solid shape, the cube. Lastly, we have one panel left, and therefore that's going to be the top panel of our 3D solid shape, the cube. Now take some time to use your imagination to fold this net to make a cube. Is there any other way that we can draw a cube's net to make the same 3D solid shape? Let's keep on going. Here we have the triangular prism. Now, these two images have already done the hard work for us by using colours. This is another way that we can identify which panel is going to be which part of the 3D solid shape. As we can see, the green panel of the net matches the green panel of the base of the 3D triangular prism. Have a look at the different colours and see if you can match them up. Do they make the 3D shape? They most certainly do. It's important to realise whether you would prefer to use numbers or coloured dots or colouring in the panels to identify how it will form in the shape. Here is the net and the 3D solid shape of a rectangular prism. Again, the images have already used colour to help us identify which part will be what of the shape. The purple in the middle, however, has become the top of this shape. How has this happened? Take a moment to try and figure out how the purple panel has become the top panel. Indeed, I believe that this net has been flipped over after it was created. Here is the net and the solid shape for a triangular pyramid. It's important to understand that when it has a triangular base, it will only be a triangular pyramid. Whereas here, we see that this is a square base pyramid, as the bottom panel is indeed a square. As I said before, there are different ways that we can identify or analyse nets to see what solid shape they'll be creating. You can use written words, such as base or letters, on your net. You can use numbers to identify what part is which on your net. Or we can use colours by colouring in each of the sections, such as green for the base, yellow for the side panels, and a different colour for the different side panels. Let's recap. Complex nets are nets that have many faces, edges, and vertices. Bottom, side, and top refer to the different panels that make our 3D solid shapes. Remember, you can either write, number, or colour in the different panels to show where they would be on the 3D solid shape. Now that you've completed this video, please work through the Keynote activities, and once you reach the assessment page, find your teacher to be assessed for this star.